This is my Commodore 128. It's been on a shelf in my attic since, since I moved into this house 29 years ago. It's got no cables, it's got no software, it's got no monitor, so there's not a lot I can do with it. Or is there? It's my intention to get it working and then, to see exactly what it's capable of. And I'd like you to accompany me on that journey. Like, subscribe, and tell your friends. Now, let's get started. This is not my first Commodore, and I suspect it won't be my last. I first came across the Commodore PET back in 1980 when I was in college, and immediately of course I wanted one, but I had to wait until the Commodore 64 came out in 1982. I love my Commodore 64. I learned to program it in BASIC and machine language. I started writing my first novel on it, which I never finished of course. Sometimes I even played games. And naturally I got the 1541 disk drive. And how disappointing that was. The tape drive was actually faster, and in fact even writing out longhand was probably faster. Possibly. The PETs we had in college shared a 4040 disk drive between two computers. You could do that with an IEEE 488. They only stored 170k on a disk, but they were fast. Incidentally, in 1980 the going rate for one 5¼ inch floppy disk was £3 per disk, never mind a box of 10. In 3, 4, 5 years they came down to pennies. Now, 2021, on eBay they're back up to £3 a single disc. Anyway, I digress. Let's take a closer look. The slimline wedge shape of the 128 looks sleek and futuristic when compared to the 64. It's much wider and deeper, but it's also flatter. And this same design crops up a few years later in the 64C. The most striking difference from the front is the keyboard. There's now a numeric keypad and an extra row of keys along the top, including a dedicated 4080 column button. On the side we've got the joystick ports, which are familiar from the C64, and the power switch, but we've also got a reset key, and now the power connector is square. The voltages are the same as on the 64, but the current draw is greater on the 128, so obviously the power supplies are not directly compatible. We're still in familiar territory. Got the cartridge port, cassette port, serial bus, video connector. That's the same 8-pin video connector that we have on the 64. The empty hole that does something in NTSC but does nothing in a PAL machine. The RF output, and a new connector here, RGBI. This is for the 80 column output. It's not quite CGA in the same way that the video is not quite S-video. And finally we have the user port, which gives us the same sort of I/O that we had in the previous machines. Turning it over, we've got 6 screws that hold the case together. So 1, 2, 3, 4, 5, 6. Let's take those out. And the case should just lift off, except, I don't know if you can see this, but underneath we've got 2 cables, one for the keyboard and one for the power LED. Now there's 3 cables to this, so it's actually keyed. So we need to remember which way around it goes. And the red cable, the red wire, is towards the front. The fat side of the connector is towards the outside. That pulls out. Now this connector is also keyed. It's exactly the same as a sort of D connector, except it's just in a square block. This earth strap should be connected to here, but for some reason the screw is missing. In here we've got RF shield. This is a metal shield, unlike the latest C64s, which had a cardboard one. And we've got 7 screws this time, and we've also got little tabs that we need to make sure are twisted out. There we go, and this should now just lift off. I've already cleaned the gunk off the top of the ICs. It was all crusty and dried out anyway and would have needed replacing. I'm probably going to leave the RF shield off and put separate heat sinks on the individual chips, because that RF shield really acts more as a heat retention device than it does a heat removal one. Okay, let's take this off. This just pulls off carefully. Come on, come on. There we go. And this reveals the video chips. So once again, I've already cleaned the gunk off these. I will be putting this shield back though, so it will need to have some new gunk put on. Okay, so what makes this machine special compared to the Commodore 64? Firstly, it has 128K of RAM. That's these chips here. There's a clue in the name. Next, it's got 2 CPUs. The 8502, which is a 2 MHz capable version of the 6510 that is in the 64, and a Zilog Z80, which runs CPM mode, and it's also the same chip that you would find in a ZX81, a Spectrum, and a whole lot of other computers of that late 70s and early 80s. The main reason for having that was because it could run CPM, which really was kind of the precursor to MS-DOS, and it was primarily for business applications. Although by the time this machine came out, CPM had basically had its day, and consequently that feature largely went unused. I bet you can probably count on one hand the number of people that actually used CPM on the Commodore 128, other than just loading up the disks and saying, oh yeah, that's CPM. Interestingly, it's the Z80 that's actually running when the computer starts, and it looks for things like the Commodore key, what's plugged into the cartridge port, and so on, to decide whether it's going to run CPM mode or 128 mode or 64 mode. Keeping going, we've got 2 6526 chips, this one here and this one here. These are the same as in the 64, as is the SID chip, which is 6581. Now we come to the video chips. 2 separate video systems. The 6566 VIC-2E chip is a variant on the VIC-2 that runs in the 64, and this handles the 40 column display. It's not the same as the one in the 64. For one thing, it's bigger. It's got 48 pins instead of 40. And the extra pins basically are used to decode the extra keys on the keyboard and provide the clock signal for the Z80 and also signal 2 MHz mode to the 8502. This is the 8566, which is the PAL version of this chip. The NTSC version is 8564. There's also a 8569 version which was used in, I think, parts of South America. Although this 8502 can run at 2 MHz, the VIC-2E only runs at 1 MHz, which means that for 40 column graphics the computer also has to run at 1 MHz. If the computer runs at 2 MHz, then the 40 column screen goes blank. There are some tricks that allow 2 MHz during 40 column mode by running it fast during the gap between lines, which gives some speed improvements, and there is some software around that does that. The other chip here, this one, is the 8563 VDC, which is the video display controller. This handles the 80 column screen, and it's primarily for a text mode display. You can run both for the 80 column, I'll point at the right thing at the right time. You can run both the 80 column and the 40 column screens at the same time and have different data on each of them. The VDC does run at 2 MHz, so you can run the 128 at full speed while you're using it. Now, the 128D CR, that's the cost reduced one in the metal case, has an updated version of this, which is an 8568. Unlike the VIC, which shares screen memory with the CPU, the VDC has its own dedicated 16K of video RAM. It's these two chips here. This does limit the display modes that can be used, but we can actually upgrade these chips to 64K, and indeed the metal case 128D CR does come with 64K here as standard. There's not a lot of software for 80 column mode, and very few games, for example, actually make use of it. I think the most common use, certainly in later time, for 80 column mode was running GEOS. Finally, we come to the ROMs. There are 4 ROM chips and 5 sockets. Basic and kernel ROMs for 128 mode, and basic and kernel ROMs for 64 mode. I would point at each chip, but I'm not sure right now which one is which. The empty socket, however, is for an add-on function ROM. Now, it does need a little bit of cleaning up, but next time I should have some cables and stuff ready that we can actually plug it in and see if it works. So if you've enjoyed this video, please like and subscribe, and we'll see you next time. See ya! Ta-ta!